they're all come with a program sheet for the ABB drive, so if that ever goes out on you and you got to replace it, you can program it fairly easily from here if they haven't made any changes. Another thing you can do is do a parameter save on the drive itself. You guys are pretty familiar with ABB. Need some information on that. So what we can do, let's do that while we're
shut it down if you like.
okay, good. So maybe we'll just do a couple things while it's still running. Change the parameters, fault logger, time and date, parameters backup. So once this gets turned over to you, I would advise doing a parameter backup, because even at startup, if I make some changes to what I wanted to do or I think it should do, controls people might come in later, they might change the input signal or do some things. So when you get a hold of it and everybody else is out of here and there aren't going to be any more changes, you go to parameter backup, and you can go, the top line is upload to panel. It may not work unless the thing's turned off. Okay, we have to shut it off first. So okay to shut it off, you can see the off button. Yeah, it's ramping down now. Back up. Pull the chips up real quick while it's ramping down. So it stopped. You go back to the menu, parameter backup, upload your panel, and select. It's copying the parameters now. Just did was we took everything about the way the drive is set up that's programmed in here, and we put it in a memory spot in here. So if the drive ever blows up and you change the whole drive, you can put this same panel back here. The new drive will come with a new panel, but use the old panel. You go back to parameter backup, and you hit download full set. It'll take everything that was in that memory and put it back in the drive. That way you don't have to mess around trying to figure out everything that it needs to be programmed.
2 billion settings.
Yeah, you know, that's the thing of it is, these drives, you know, they came out for industrial to begin with, you know, 30 years ago. They have 1,000 parameters in them. For HVAC, you only need a dozen or so. There are some new units now that are coming out with an abbreviated drive and a separate panel that looks at all the drives for every motor, and they only have a few parameters. But you're right, you got to wait 1,000 things to figure out what you do and don't need. Another nice part is, if it gets to the worst case, you can go back to Hunter's settings here, and then try to figure out what maybe has been trouble since installation. Also, I think a way to load them to a laptop is something like that. So, the drive itself, you can manipulate up and down and then in and out of menus. And then there's a handoff auto button. The auto position is where you want it all the time for operation for the building management system. If that should fail and you need to operate it in hand, you can use the hand button. Sometimes that won't work unless the start signal is made from the controls contractor.
So you got to do it through BMS and this as well?
Well, you can, if that system's down and you really need to get to it, the safety contact is here. See, there's a 110 volt circuit for all the controls in here. You come down here and the first line goes up to the safety circuit, normally open. And then you can add other safeties. Looks like you have a door switch on this as well. If you open the door, it shuts it down. But CR3 in this case, first thing it does is block everything below that line. So if the safety trips, this opens up, you don't have any power for all the rest of the controls. So once the safety circuit is made, then you're looking at the auto start contact here. You may have to make that depending on how it's programmed to get the hand operation to work. There will be a slight difference in the wiring diagram for the one that has 2 drives on it. You will see some additions here from this switch, and there will be an auto changeover. So there's a contact that comes from the drive that's from each drive. And if one drive blows up, goes an alarm or something, it switches in alarm contacts, it'll automatically switch to the other drive. Look at the lights. So you see that's got 2 blue lights. Here we have VFD and bypass. Over there we probably have VFD 1 and 2. So the key on that would be if you're selected for VFD 1, for example, over there, and the light is on number 2. The alarm is on, then we have a VFD alarm that's switched over. Let's see, let's get on to what we have here. So we may take a peek into that one as well. We got input line, fuse disconnect, being a power block here. The power block, which is 2 of them here, one's going over here, feed the drive and the transformer. The lighting transformer. So you got a transformer in here that also powers this. Circuit breakers are here for the high voltage side of this. The circuit breaker for the low voltage side. The Pro Power transformer has high side voltages, fuses, and low side voltage. If it's black, it's high voltage. If it's red, it's 110. All the red wires, including the lights here, the switches are all 110 volts. Everything else is different color, yellow, signal wires, stuff from the controls contractor, that's all local. This is all controls contractor stuff. This one has a 3 contactors. One is for the input to the drive, one is for the output of the drive, and the other is for the bypass. I think so. It's up real quick here. Okay. Maximum frequency on this drive is 100 hertz. Normal frequency on a motor is 60 hertz, so we're going 75% more than normal speed. Obviously, if we blow the drive up and have to use bypass, we're only going to get 60 hertz. So you won't be at full capacity in this unit if you have to go to bypass. A unit with dual drives on it, you just switch over the other drive and you'll have full capacity. In this case, 6 motors in here. Each one has a circuit breaker. Each one has a contact that says the circuit breaker is in place right now in the on position. If one of these motors trips, I still have this off. I don't want to get this off later. It's still right. It's still off. If it trips, you're going to see a minimum position like you do in a regular circuit breaker trip. You see that, the motor's been tripped. That's the off position. So in the trip position, you want to take a look at the motor, see if it overamp, or did it blow up, did it go on the ground. If something happens to one of these motors very violently and it causes enough current, you're going to take the drive down, go off on current limit, or you might take a fuse out somewhere here, or something that would cause it to go down. In a lot of cases, when we have multiple motors like this, we just trip one motor. You walk in, you'll see that light on. It says you got a motor out, and your circuit breaker will be in trip position. External fault light is supposed to be on. There may be a problem with the light. That light is series to all these connections. I'll double check that wiring diagram. Usually you've got a fault, external fault, some sort of fault would be on there. Sometimes they, depending on how they wire it up, it may just be wired to a set of contacts here. Let's see what we got on this one. TV1 151 P6. Yeah. 151 and 152. In this case, they just ran them to a set of contacts here. So you can put a set of wires on there and tell whether it's open or closed. They opted not to do it. Closed contractor. But you could pick it up there and it would give you a signal somewhere, whatever you want to do with that signal. Here. In some cases, they'll wire each one of these separately and put a light on every motor. So if you walk up to it, you see a light on, that one's out. Sometimes they put them in series only to one light. In this case, they expected it to be monitored somewhere else. The external fault light and VFD fault lights are the best things that are going on in here. From the VFD fault, the alarm goes on in here. You get that light. The external fault tells you there's something outside of the unit that's on. So let's see an example. Hooked up like this. The external fault indicator is only on CR3, the same relay we talked about earlier. Again, if that safety line is open in any way, that light comes on. So that's going to include whatever safeties have been field installed and this door switch. I don't know if it's on this door. Got that locked. We're going in there in a minute.
Didn't make it easy, could they?
No, I'm not real crazy about these things anyway. I had a door slam on me one time and bent that thing. The next time I went in there, Here, relay click when I open the door. External faults. Between that, probably the rest of them are like fire safety shutdown, whatever else. Duct high limit, maybe close contact. Any questions on what's in there? There's a little temperature switch up in the quarters, measuring the temperature on this back plane here. Turns on the cooling fan. Cooling air comes from inside the unit right here. Right now we can shut off and close this. It's just going to pull a negative and pull air out of there. That's coming out of this high side pressure cabinet. So when this is running, you'll have air blowing in there from the unit. Actually on the other side of the phone, so in this case, since you have hot and chill water flow, it should be coming from prior to the hot water. So when you make this one of those guys,
Melting.
Yeah.
well, yeah,
To keep it cool.
job down in unit was designed so that the hot water coil was just supposed to take the chill off the outside air. And now we're supposed to go with 70 degrees. So I said, okay, we can plug that in there. General contractor decided a good way to dry out the recarpeting of the building would be to take that temperature way out. Yeah.
Take a look inside.
Yep, we're okay with everything and the controls and all that.
If the VFD fries, you use the VFD, we gotta go to bypass. That can take out the parameter. You don't save it.
Yeah, I could.
I'll bring your cell phone out when you're in this room. What happens if you drop your keys? Bend over and drop your glasses.
There's a grate, but they're pretty big.
What if we go get
I want to get a strap to your glasses. You drop them in there. Forget it.
You want to see how it feels? So sometimes this goes out here.
Right.
Take it with you. Because if you get a breach between the high voltage and the low voltage side of the circuit boards, you can send high voltage back here and that up too. So that's why I say you can always go back to this, or if you have a leverage and whatever.
You can laminate that, put it on the prints as well as belts, and
But there, you know, there's almost always some trick. If you followed all this and said, well, it's still not working, I'd go over there and see what they did over there. We have enough stuff here that somewhere or another you'll get it. And chances are, if you take that out, you're probably going to hire someone to put one in anyway. You know, just let them know where the parameters are.
Acco down here coming through.
Yeah, that's what we do.
We had that happen before in our building. Well, there we have one VFD, the van, we have to run bypass.
Yeah, and again, in this case, you're only going to get 60 hertz part capacity. Over here, it looks like cool. Open that up and see what's in there. You see it lit. Run both drives all the time. I don't think so. They're usually back up there.
The way this one's ours.
What is it normally running at?
We can make something for birds here.
Depends on your load.
Yeah, we run that for man jack.
You know how many boxes are open and cooling, they're wide open, closed down. You're probably going to control duct static. The OR, that's probably going to be full outside air and constant volume. The only reason you put a drive on that is to compensate for filter loading.
Yeah, what they're going to do is if ORs are down for a couple hours, it'll ramp down to 25%, save energy. So it's like at night, because we don't do 24/7 surgeries. So at night it'll ramp down. We have to set up controls. When they go in and turn the lights on and touch the room, we'll start firing up. Ramp up.
Yeah, go ahead and close that.
Yeah, we're going to go in there for a second anyways. I want to point out a couple of things. Hit the light switch there and see if it works.
Doesn't do a whole lot of good.
Yeah,
Push up
pinch
in the
that
middle.
little thing in the bottom. Yeah, I don't like those colors.
Yeah, we definitely have to put a bright
It takes a little while for that. That's one of those LED things.
Yeah.
It'll get brighter.
And now they're making those smaller and smaller, aren't they?
Yeah.
This one, is that the same size or?
Like a little Phillips.
You need a bitty fill.
How about that? Would that work?
Yeah.
That's all I gave you.
I think if you're smart enough to figure that out, you can go in a hot panel.
Yep. Only four fan motors, two contactors, one or the other. There is no auto changeover, rotation, any of that. So, however, here's the difference in the line we were talking about. This switch, you just select from one drive to the other. Over there you got on, off, and a bypass. Notice how it goes down two parallel lines. There's contacts in between. These contacts are driven by the alarms in here. So if I select this drive, it's running this contactor output to the motors, and that drive goes into alarm. Switch here and open here. So this contact line will now come down through here. Even though I've selected for drive 1, it'll pull in the contactor for drive 2. And that will happen automatically. Easiest way to tell is you come up here, you see that on 1 and it says 2 is running. Or VFD fault lights on. Never like to trust these lights too much though, because they burn out. They are better now because they get the solid state lights instead of the bulbs. So
That's nice.
they do last a lot longer, but I still have had some bad, you know. Never trust a light. And that, there's a 2-way difference in here. The airflow things we didn't talk about over there are here. There's a set of tubes on the inlet cone. Probably one for one set, one for the other set. Over there we had 2, one for each 3 fans, because we had 6 over there. So what they do is they have on the inlet cone itself, it's curved where the air comes in. A little hole here and a little hole up here. They're actually just measuring the difference in pressure between where the air comes in and where it's lowest in the system. That pressure differential is on the transducer here. This is programmed to accept that milliamp signal and convert it to a CFM count. So that's why you see airflows here.
That's actually CFM pressure diff one pressure.
Well,
Or is it supposed to be reading CFM? Or?
yeah. And it's probably it's on a linear scale, and you know nothing's ever perfectly linear. But it's also comes back. One of these sets here also comes back to a set of contacts here. Those contacts are supposed to pick that up. So when he gets a copy, whatever the milliamp signal is here, he gets copied back here on the terminals. You can pick that up, and what he's supposed to do is take the information off of here on the unit that says 420 milliamps equals 0 to 40,000 CFM or whatever it is. Now that doesn't mean you'll get 40,000 or you'll ever see the 40 milliamps. That's just the way it's programmed for that cone and that fan. So your actual, you might only be designed for 20,000, but he'll scale it. It should be on here. This is an older unit. I actually don't use that style anymore. And on the new ones, since I've had so many calls from these where people ask, you know, how do I scale my thing? They now print it on the bar diagram, but it's not on this one. However, program sheet here for it. Maximum CFM is 26,650. But I would, before I trusted these numbers, always look at this guy up here that says this figure sheet is for AHU3, because during construction you have to shift it all over. So we're actually on AHU3, that's the right sheet. This is how that thing is programmed. If this goes out, with that information, project number, which is their idea of the serial number, and you tell them you need one of those, they're supposed to program it before they put it in the box and send it to you, if you get it from out there. You can buy them yourself, do this too. This is cumbersome. It's sort of like telling you you need to do everything with 2 program buttons. So that gets kind of, unless you're used to doing them, they're kind of hard to do. Anything else?
The 2 drives on this unit, just because this unit is so important, has to keep running as a backup, right? And it doesn't transfer over to any of the other units, it just stays on H3.
Yeah, you know what, my personal opinion is part of a maintenance program should be to switch them over.
Yeah.
Because,
Part of our line starter maintenance.
you know, that's, say one of the reasons I don't like the idea of a nuclear power plant is because it seems like every time you switch to a backup, it doesn't work. Because it sits around and rusts stuff, nobody uses it. Then when you really need it, it fails. So,
Do you recommend semi-annual on that? Annual?
yeah, 6 months or every month. Some people put alternators on them and change them once a week.
Yeah.
Just to give them equal run time.
Come out.
Give them equal run time. You know they're working. You know that you know something didn't drop into this one. And
Good idea.
you know, all it takes is one metal shaving. You know, drill a hole up there and drop a metal shaving in there, take that drive out. So, good idea to keep them up and running. You know they work when you need them.
It's just me and you are whistling though.
Sounds like so many so you were saying something about the lights, like, you know, how you don't trust them because they burn out, right? What's the better way of checking whatever that fault is?
Oh. Well, you know, you would also get a fault on the drive display and still lit up. The problem with drives is, and even on that relay, right? In order for that relay to work, the drive's got to work. So if the drive is fairly intact and it blows up, say, an output rectifier or something, input rectifier, an output transistor or something, and there's still enough of it in place on the control side of it that says, well, I have a problem, I'm going to shut down. I'm going to go into alarm and I'm going to switch my contacts, then the other one will come up and run. If it just plain blows up, it's down. They can't do anything about it.
Is there a lamp test on this for the faults?
No. See, a good way to put VFD, check a fault light. Or if you wanted to check this switching over thing, find it.
It's okay to just turn the switch anytime. You don't have to ramp anything down or anything like that.
You shouldn't have to.
Do you recommend ramping it down and shutting one off, switching it over, and then bringing the power back on?
It's always better to do that. You know, if you make a mistake and you didn't realize it came up to run and you wanted to switch it over, you can just switch it over. So what's going to happen is it's going to pull the output contact. The output contactors have an auxiliary contact that's in line with the start and stop there that says shut down now. This is not in place. And then you should be able to switch over. Fault function.
Good? Easier?
Communication error says last speed. So if you unplug the cable here, it's supposed to go to its last speed. You can set that for a fault. And then the cable is liable to go to fault. But only if it's in the force will flow, watch it change over. I don't know what else you can do other than pull the wire off. Turn the power off, pull the wire off the contact, and follows through and see if it switches over. You know, simulate an alarm in some way. Then you can check your auto changeover function.
That's considered uphill too.
That's a bit tricky with it. You know, I've had to do it in the past. Take that panel display thing, so you can pull the cable, it loses communication with this because of the alarm. Hey, where are you going to go?
And now this has two VFDs and these two heads, and they store the memory of the settings, right? Now are they interchangeable?
Yes.
Okay. So if one goes down and one loses or something, we gotta replace it. We could just get the information off of here and download it into that one, right?
We want to label these because you can actually take this head, put it on that unit, or you can take it over and put it on.
Are they all the
other
same
one.
though? Is it all the
They're all the
same?
same on this building. All
Okay.
our drives are the same. They're all
Okay.
interchangeable. So we want to label them so we don't put the wrong parameter
Right.
head on the wrong unit if somebody starts spinning.
But they are all interchangeable though,
Yes.
right? So they can essentially be put in
Not
every
programmed
single
the
one.
same, though.
Not programmed.
This one has 4 motors, that one is
Okay.
6.
Okay.
Different amp ratings.
Okay.
Basically,
Okay.
it's working like a keypad though. If you want to turn a unit off and the head's it broke on that one, let's say, you could take this head, bring it over there, turn it on,
Right.
and it'll run on the internal
Sure.
VFD drives information, not the head information.
Right. As long as you don't download that
Exactly. As long as
information
you
into
don't
the
download
drive.
the parameters.
Okay. Got it.
In fact, that's what us lazy startup people do. We program this one, then we go back there and we switch them and download it to the other one.
Yeah,
And
yeah.
then you've got 2 programming at the time of one in a quarter.
Yeah, in fact, on jobs where they're loose, I don't take them off the wall usually, but sometimes we'll have like 10 exhaust fans on the roof. Pull it off, stick the neck, just carry it around when you turn it on.
Is that
But as far as these two, they're completely interchangeable, right?
Yes.
Because they're the same settings and same
Someone
programming.
did the upload, which is why I'm telling you,
Yeah.
do the upload. so
Sure.
you have it.
Uh huh.
is that fan back there like water resistant? Like when it rains, is it gonna suck in?
This?
No, the fan here.
That's exhaust.
Oh, yeah.
It's
Yeah, that's
exhaust.
air
It
being
doesn't
pushed
suck
out.
it in.
Oh, okay.
The air's coming from inside the unit through a conduit into the cabin from the bottom. So the air comes from inside through here. That way it's filtered already. We don't have to worry about filters or anything like that,
Oh, okay.
like we do on the other VFDs. We've got an outdoor enclosure on the VFD for a fan on the other side, and they recommend we put a filter in that screen because that fan will just draw dirt from outside into the unit
There you go. You
across
got
the
it.
heat sink.
Yeah, you might even be better off just because after it comes off the chilled water cloud, to have less moisture in it too.
Okay.
So you don't have to worry as much about rust, corrosion and stuff.
That is the main speed for you.
Yep. That should kill everything. You gotta leave something up when you look at the fire, something temporary.
Should we label it though?
Because you're supposed to turn it off before you go in there.
Should we label what's on position, off position, or how do you know?
The red thing points to it. The bezel doesn't turn. So if I turn this, it'll point. The red will point to off.
I gotcha.
You just can't see it beyond.
Yeah,
it's
yeah.
so high.
Yeah, I see.
So if you want to talk about maintenance, we're really only saying that, the fans you can't grease them, or, there's no belts. All you do is look at them. Over here, you got, clean your condensate pan and change your filters, and there's not much else to do on it.
Wait, there's no
cleaning
belts?
necessary on the coils.
belts.
Filters.
Direct, sorry.
And then,
Coils don't need to be cleaned as long as the filters are taken care of, right?
and then the motor doesn't need
Nothing.
greasing. So it's like you don't do nothing to them.
So we have to have the cleanest pans in town.
That's great.
How long you recommend to clean the pants? 6 months?
Yeah, I don't know. This is San Francisco, you probably don't even use the chill water cloud.
Not too much.
There's 2.
Except if you want to dehumidifier if it gets too hot and foggy, right?
Actually, this unit's got humidifiers in it, I believe, too.
Oh, it doesn't.
I believe so.
I know it has humidifier. I don't know about dehumidifier because it has humidifiers.
Yeah, we definitely have a
We have it
humidifier in here.
downstairs in the dog.
No, they actually opened one of these up and showed us.
Yeah, there was steam. It was like a bunch of spray.
You have your own steam.
Yeah, yeah.
I don't know about steam, but it was like sprayer. It was a sprayer, I think.
Low pressure steam.
Oh, okay, this thing.
So you got chill water, hot water, and steam.
Yeah, low pressure condensate.
Oh, is that one over there?
Yeah, so this, right here, steam supply. Yeah, it's got a half block.
Yeah.
But yeah, we got a humidifier right in here that will keep us at. It probably won't run much because in San Francisco our humidity outside is so high already.
This is the place to put it because I got a lot of most of the houses I started up the last few years all over the Bay Area. Instead of doing this, they put the steam outlets right in the operating rooms, their own individual controls, their own
We do have 3 in the building too, 2 in the building, but not in the
They
ORs.
send a 55-degree air into there, and then they hit the steam, and it comes out of it freaks the doctors out.
Yeah.
It just looks like the place is on fire.
Yeah.
We have in the
It's a bad way to
ICU
go.
ward, we have steam injectors on the 6th floor, but we're probably going to turn them off once it's all said and done. We don't need them. Had to
That
put them in
happens
because the
both
state
places.
said to put them in.
It's a requirement, I think of a state regulation
Yeah.
or something. But nobody needs them in the Bay Area, so they just turn them all off. Yeah, they got 100 and some of them over in that Kaiser high rise in Oakland they just put up. 100 and some dry steam humidifiers, each one in its own little tank, in recovery rooms, in bedrooms, in operating rooms, and all those things. Talk about a maintenance headache. Would you like replace and or clean,
Right, that's almost a
100 and
full-time
some
job.
humidifiers.
This is targeted by Jack London Square.
No, this is Broadway and Clark. Oh, right there. Yeah.
Or is it possible? Can you show us how to clean the pan, or do you guys know already?
Right, just gotta open the door and then you're gonna have you'll see the pan under the coil, and we're gonna get in there with probably some hot soap and water and start at one end and just kind of push it through, and then you get to the other end, we'll put a bucket in the pan and let it force, try to rinse it out. We've got traps, well this is the steam, we got a trap right there that we can clean the traps, because any of the debris that we push and wash through, we can open up the cleanouts down there and then
Looks
it'll
like
drain
this
the
right
trap.
here,
This is
too.
for the steam.
Yeah.
Or actually this is probably for the steam, and that one's for the coil.
Yeah.
Is that trap with the ball? What's that? No, you see that right here? This is the trap. Okay. They might. Because we are moving, you see a lot of water coming out of this. We are moving condensate.
Put a thing in there, collect a gallon of water in a couple of minutes.
Yeah.
Nice to see it look right. See, like right here, these are both probably a primary and secondary. I'm not sure. We'd have to open up the door to see what the pans look like. But they're nothing. They're nothing to clean. That's just for the scrap here.
No, just put it there to confuse you. It's like, where's that go?
That's nice that they've got notch flushes on both sides, so it'll be real easy to clean these pans. So